Okay, so let's just dive right in. You've seen the term AI PC everywhere, right? It's the big buzzword. But what is it actually going to mean for the computer you buy in, say, 2026? We're going to cut through all that marketing noise and get right down to the hardware that really, truly matters. So this leads us to the big question, probably the one on your mind. Is your next computer, your next laptop, going to be some kind of personal AI supercomputer? Well, the honest answer is it's complicated. It really, really depends on what you're actually trying to do with it. See, here's the thing you have to understand. For years, all the really heavy-duty AI stuff has lived out there in the cloud, running on these gigantic remote server farms. But that's all changing. In 2026, AI is finally coming home. It's moving from the data center right onto our desks, which means the actual hardware inside our machines has never been more important. All right, so let's get real. Let's talk about that hardware reality. What are the components that are actually going to power these new AI experiences? And more importantly, how do you and I separate the genuine game changers from, the empty buzzwords? Think about a modern computer's brain. It's not just one thing anymore. It's really made up of three key parts. You've got the good old CPU, that's kind of the general manager of the whole operation. Then you have the GPU, which is the heavy lifting specialist for tough jobs. And now you've got this new player on the scene, the NPU, or neural processing unit. Each one has a very different, very specialized role to play when it comes to AI. So this NPU, this is what most of that AI PC marketing is really talking about. And look, it's amazing for small, super efficient tasks that are always running in the background. Things like blurring your background on a video call or giving you instant voice transcriptions. It's the perfect assistant for sure. But it is not the heavy lifter. It's not what you need for the really serious AI work. And this right here, this is the heart of the whole discussion. On one side, you've got those quick, bursty little tasks that are perfect for an NPU, those fun consumer features. But on the other side, well, that's where you have the professional workloads. We're talking sustained, hours-long processing, training AI models from scratch, analyzing massive data sets. That stuff requires a completely different kind of engine, and that engine is the GPU. Okay, so to make sense of all this, let's think about AI hardware as a ladder of power. We're going to start on the bottom rung with what consumers can get, and we're going to climb all the way up to the kind of insane machines that are literally building the future of AI. So here we are, rung number one. This is for the prosumer, the individual developer. The creators, the coders, the video editors out there who need some serious horsepower, but they need it in a package they can actually put on their desk or even toss in a backpack. And a fantastic example of this is what we're all expecting to see from Apple in early 2026 with their M5 chips. The M5 Pro, it's going to be perfect for developers and video editors, giving them that great sweet spot of power and efficiency. But if you're a 3D artist or a serious AI pro, you're going to be looking at the M5 Max. With an expected 40-core GPU, that is the absolute pinnacle of what you'll be able to get in a consumer machine. But wait, what if you're a developer who needs to get even closer to the hardware? Someone who needs to squeeze every single last drop of performance out of their machine? Well, for that person, there's a whole other path. For a ton of AI developers, the ultimate setup is building a custom PC and running Linux. And this quote from KS Royal on YouTube just nails why. Linux gives the AI model direct, super low latency access to the GPU's own memory. It's VRAM. Just picture it like a private, high-speed superhighway for data. It gives you a massive speed boost that you just can't get on other operating systems. Okay, time to climb. Let's head up to the next rung on our ladder. This is for the serious professional. We're talking researchers, enterprise teams, the people who are pushing up against the absolute limits of even the most powerful consumer gear. And up here, we enter a whole new world, enterprise-grade hardware, like NVIDIA's RTX Pro series. Now, the key number to look at on this slide is 96 gigabytes of VRAM. For a professional who's trying to fine-tune a massive AI model, memory is always the bottleneck. A card like this doesn't just make things faster, it makes entirely new scales of work even possible, work that would just be impossible on consumer hardware. And now, we've reached the top of the ladder. We're at the very top. This isn't just about speed anymore. This is about mission-critical work, where security, rock-solid reliability, and just immense power are completely non-negotiable. This thing you're looking at, this is a Talano workstation. and it's a perfect example of this top tier. Yeah, it doesn't look like your PC at home because it's not. These are purpose-built systems for fields like digital forensics, intelligence, legal discovery, places where processing massive, highly sensitive datasets offline isn't just a nice-to-have, it is a hard requirement. At the absolute peak of this workstation ladder, the numbers just start to get kind of insane. Take the NVIDIA DGX Spark, for example. It features 128 gigabytes of unified memory. What that means is the CPU and GPU share this massive pool of incredibly fast memory, which just eliminates bottlenecks. It's not just a powerful workstation anymore, it's basically a personal supercomputer sitting on your desk. So we've seen all this incredible power, but you might be wondering, with all the powerful AI available in the cloud, why on earth is it so critical for some people to have all this processing power running locally on their own machine? Well, it's about a lot more than just speed. For a huge number of professionals, working offline isn't a choice, it is a necessity. I mean, when you are dealing with classified information, sensitive intellectual property, or critical legal evidence, the cloud just isn't an option. Your local machine has to become a secure fortress for your data. And here are the concrete reasons why. You've got legal rules that can actually forbid data from ever leaving a country. In forensics, you have to maintain a perfect, unbroken chain of custody for evidence. In R&D, you have to protect your trade secrets. In all of these situations, the AI has to run locally in a secure, totally air-gapped environment, which means it's completely disconnected from the internet. So, okay, we've climbed this whole ladder of power. We've seen it all. What's the big takeaway here? How should you be thinking about choosing your own AI engine come 2026? This is the most important thing to remember. There is no such thing as the single best AI computer. The goal is to find the right machine for the specific job you need to do. It doesn't matter if it's an NPU handling a video call, an M5 Max rendering a complex 3D model, or a Talino workstation processing forensic evidence. The workload always defines the hardware. And that really leaves us with one final big question to think about. As AI gets more and more woven into our daily lives, running on our personal devices, learning our habits, we have to ask ourselves a pretty fundamental question. When your AI knows you best, where do you want it to live? On some remote server, somewhere out there, or right there with you?